So hi friend, this is a continuation of previous lecture upon that KVL KCL. I did with some mathematical examples and very new mathematical examples and more mathematical examples on that KVL and KCL will be coming out very shortly. So my today's topic is node analysis and the mesh analysis. So what is node? Let us consider one particular circuit like this. So first you have to put the heading node analysis. In this case you can see that suppose this particular circuit has made, that is say this is R1, this is R2, this is R3, this is R4, this is R5, and suppose one voltage source V is adjusted on that and the current is running as I. So the current is taking branches as I1, here it is as I2, here it is I3, here it is I4, here it is I5. So what is that node analysis? That node analysis says that if you are using KCL at many more times in a complex and bigger network, so obviously this particular subject analysis is called the node analysis. Why this is so? Now in this particular circuit, that is say question number A, we are seeing that is node A, that is node B in this way. So if I am taking that KCL, okay, called as a node analysis, so what should I write? In this case you can write that I equals to I2 plus I1, because it is entering current, it is outgoing current. Here same way that I2 equals to I3 plus I4. Here I can see that all total I4 equals to I5 because they are the same, symmetrical. So in this way, if you want to find out what is the VA equals to I1 R1, or you can write that is equals to I2 R2. So if is the same, so you can write that I1 R1 equals to I2 R2. So if these two things is known to you, you can easily find out what is the ratio of I1 and I2. If the total value I is known to you, so you can easily find out what is that value of I and proportionate with I1 and I2. So that is called the node analysis. So what is the mesh analysis? In that mesh analysis, actually we are applying KVL in the same way. So suppose that is a circuit, that is a resistance, we already have fabricated it before, as you can see my previous one, and this is V. Suppose this is R1, R2, R3, R4, R5. So let us consider I1 is here, I2 is here, and I3 is here. So all these branch current are circulating in this particular case. Now I can easily mark it as A, B, C, D. So the current here is I1. For this is EF, I can write F8. So it is B, E, F, C. In this particular circuit, the current is I2. In the next branch, it is I3. In this way. So if I apply KVL, actually in that mesh analysis we are applying KVL many more times, multiple times. We apply KVL for ABCD. What will be getting that if we are applying for KVL ABCD, we will be getting that V minus I1 R1 here plus this is I1 and this is I2, so plus I2 R1 equals to 0. Or you can write that V minus as a common I1 minus I2 R1 equals to 0. In the same way, for if you are considering loop 2, so what should I write? That I2 minus I1 here, I2 minus I1 of R1, I2 minus R1 into R1 plus I2 R2 here, and for this case it is I2 here and I3 here, so I2 minus I3. I2 minus I3 into R3 equals to 0. Okay, that is for loop 2. And what is for loop 3? For loop 3 you can write as I3 minus I2 into R3, this one, plus I3 R4 plus I3 R5, that is equals to 0. So as you can see that if it is I, so I is taking branches in this way, I1 and I2. So in this way you can write that using KCL, you can again write that I equals to I1 plus I2. Therefore what is V of R1 means the drop across this is this I1 R1. Now you know that I1 R1 equals to I2 R2, so we can again write that I1 equals to R2 divided by R1 plus R2 into I, and I2 equals to R1 by R1 plus R2 into I. Okay, so finally we can conclude what is V R1, because this particular I1 value will be substituted like this particular point. So we may have one mathematical examples on this. So here in this case one particular point is given. This is 15, this is 10, this is 5, this is 50 volt, and this is 100 volt. So finally you have to calculate I. So here it is given that calculate I. So you have to calculate I. So how to do this? You have to do that here. If it is applying, if you are applying KCL, right, so what will happen, that IAB equals to I plus IBC. So here this I taking in this way, so it is IAB, that is I, and IBC. So I can write at 50 minus V by 5, here it is V, say, equals to V by 10 plus V minus 100 by 15. Solving, we are getting that V equals to 500 by 11, and I equals to V by 10 equals to 50 by 11 ampere. So you can easily solve this particular problem by using KVL also. If you are using KVL, so we have to solve in this way, that 50 equals to 5I1. Why? Because then this branch will be having I1 current, this branch will be having I2 current. So 5I1 plus 10 I1 minus I2. Okay? That is the equation. So we'll be getting that 50 equals to 15I1 minus 10I2. That is 1. So again we can write that loop 2, if you are considering, so 10 I2 minus I1 equals to minus 15 I2 minus 100. Solving this, we will be getting that I1 equals to 10 by 11 and I2 equals to 40 by 11. So minus, so I equals to I1 plus I2 equals to 50 by 11. Adding them up both ampere. So using KVL, using KCL, both things can be solved. This is called that node analysis and this is called the mesh analysis. Okay, thank you for all this particular video. More examples, more things will be coming out in future. So in this today's video, I think you have learned what is KVL, what is KCL, what is mesh and what is node analysis. So more examples, more mathematical problems I will solve in future. So please go through my teaching, go through my channel, and if really you like this, you can subscribe my channel. Thank you very much for listening.